Welcome to The Explainer. All right, we're going to jump right into a real head-scratcher today. How is it possible to use something boiling hot to make something ice cold?
I mean, just think about it for a second. Steam is, well, it's hot, right? It's literally just boiling water. So how on earth could you possibly use it?
To create refrigeration? It sounds totally backward, doesn't it? But believe it or not, this isn't some kind of magic trick. It's actually a super clever bit of engineering that all comes down to one really simple but really powerful idea.
And the secret to this whole thing? Well, it's a process that nature has been using forever, evaporation. You know, it's the same reason you feel cooler when sweat dries on your skin. This whole system just takes that exact same idea and, well, puts it on steroids.
Okay, so let's get into it. How does this crazy process actually work? Let's break down the science of cooling something down with hot steam.
First thing you need to know is that instead of all those complex chemicals you'd find in, say, your fridge or your AC, this system uses just one main ingredient: plain old water. I mean, it doesn't get much safer, cheaper, or more abundant than that.
All right, now for the real secret sauce. The entire system, the whole shebang, is built around one single, absolutely crucial piece of physics.
And here it is, flash evaporation. See, what most of us forget from science class is that water doesn't only boil at 100 Celsius. It'll actually boil at a much, much lower temperature if you just drop the pressure around it. And if you drop that pressure really fast, you get this thing called flash evaporation.
So here's how that works. Imagine you've got some warm water. You suddenly suck all the air out from above it, dropping the pressure. A little bit of that water has no choice but to instantly turn into vapor. But to do that, it needs energy, right? And where does it get that energy? It steals heat from the rest of the water. The result is that the water left behind gets super cold, almost instantly.
And this right here, this is the place where all the magic happens. We're looking at the flash tank. It's the heart of the whole system. It's in here that the super low pressure does its thing, forcing that warm water to become chilled water in, well, a flash.
Okay, so now that we get the basic principle, let's zoom out a bit. How do we turn this one cool trick into a full-on refrigeration system that runs continuously?
All right, I know this diagram might look a little complicated, but stick with me, it's actually pretty straightforward. We're just going to follow the journey of the water and the steam as it moves through this whole cycle piece by piece.
So everything starts here, at the boiler. You can think of this as the engine of the whole operation. Its only job is to create really high-pressure steam. That steam is what's going to power everything else.
Okay, so that steam gets blasted through this special nozzle. As it shoots out, it expands and accelerates like crazy. We're talking supersonic speeds. And this super fast jet of steam creates a powerful vacuum, a zone of super low pressure, right in its wake.
And that vacuum is the key to everything. See, it's hooked up to that flash tank we saw earlier. It's constantly sucking water vapor out of the tank. And by constantly pulling that vapor away, it keeps the pressure low in there, which forces the water to just keep on flash evaporating and getting colder and colder and colder.
Okay, so what happens to all that steam? Well, both the original steam and the vapor it pulled from the tank go into this part called the diffuser. The diffuser is shaped to make the steam slow down, and as it slows, the pressure goes back up. From there, it all goes into the condenser, which, condenses it, turns it all back into liquid water. And that water gets sent right back to the start to do it all over again. It's a closed loop.
So, okay, we get how it works now. But the big question is it actually any good? Like, why aren't we all using this? Let's get into the pros and cons.
Okay, the trade-offs. On the plus side, it's beautifully simple. I mean, there's basically only one moving part, a pump. That makes it super reliable, really quiet, and easy to take care of. And of course, using water is a huge win for the environment. But there are some big downsides. It's not great for getting things really cold, kind of bottoms out around 4 Celsius. It also needs a massive condenser, and you need a whole steam power plant to run it, which is not exactly cheap.
So after all that, what's the point? Why are we even talking about what seems like a kind of old school piece of tech?
Well, I think it's because this is just a beautiful example of how the cleverest solutions are often the simplest. It's a testament to just taking a basic rule of physics, the link between pressure and temperature, and using it in this really direct, really smart way.
And that really leaves us with one last big question to think about, right? As we're all looking for greener, more sustainable ways to do, Well, everything. What can we learn from a technology like this? A technology that makes cold from heat, using nothing but water. It kind of makes you wonder what other simple, powerful ideas are just sitting there, waiting for us to rediscover them.